Since inventing the first hard rock tunnel boring machine more than 50 years ago, the Robbins Company has expanded its capabilities to include small diameter machines for utility tunneling. Today, Robbins offers a full line of small boring units, or SBUs, for both hard rock and mixed ground conditions. Robbins takes into consideration all of the project variables, including ground conditions and crossing length, as well as line and grade requirements before recommending a machine for your next project. The standard small boring unit, or SBUA, can excavate short crossings of less than 100 feet all the way up to 500 feet or 30 meters to 150 meters, depending on geology. The Robbins small boring unit is available in diameters from 24 to 72 inches or 600 millimeters to 1.8 meters and is used in conjunction with any standard auger boring machine or ABM. This video explains how Robbins SBUAs and ABMs work and why they are the tool of choice for utility contractors worldwide. Robbins offers auger boring machines from 36 inches to over 72 inches, or 900 millimeters to over 1.8 meters in diameter, set to the highest standards in the industry. They have been designed with the difficult projects in mind, including tough rock bores that make them ideal for contractors using Robbins SBUs. Before boring, a rectangular pit must be excavated for the machinery to start working. A concrete pad or gravel set to the project's line and grade is installed in the pit. A vertical concrete block, typically 18 inches or 45 centimeters thick, is poured at the face of the bore pit to assist in launching the SBU. This block is similar to the thrust block typically poured at the back of the pit, which provides a solid area for the ABM to thrust off of. Track is laid on the floor of the pit, followed by the ABM. The ABM can be split into sections to reduce the overall size of the crane or excavator used to install it. After ABM installation, the lead casing with the SBUA attached is set in place. Here, a 42-inch or 1-meter diameter SBUA is being readied for a 100-foot or 30-meter long road crossing in Nashville, Tennessee. The SBUA design takes a cue from larger diameter tunnel boring machines. The unit consists of a hexagonal drive shaft and circular cutter head mounted with single disc cutters ranging from 6.5 inches to 14 inches depending on the bore diameter. The disc cutters are capable of excavating rock strengths from 4,000 to over 25,000 psi or 25 to over 175 MPa. Large openings, called muck scrapers, are designed to scoop up and transfer cobbles and boulders from the rock face. Before machine launch, crews weld the SBUA to the lead steel casing, a type of pipe that will allow the transfer of the highest thrust loads to the cutting face without joint deformation, and will provide a stable environment in which to lay carrier pipe after the bore. Excavation begins in a standard size ABM launch pit, approximately 12 feet wide by 35 feet long, or 4 meters by 11 meters. This one measures about 20 feet wide and 40 feet long, or 6 meters by 12 meters. The SBUA is lowered into the pit and the casing is attached to the auger boring machine. Within the casing is the full-face auger string, used for spoil removal once excavation begins. During a push, the ABM provides forward thrust to the SBUA through the casing, while torque is applied through the full-face auger. The auger is built with standard hex sizes that allow engagement with the SBUA hexagonal drive shaft. As the cutter head turns, the disc cutters make contact with the rock face and begin to roll. The cutters move in concentric circles. As the force on the cutter head increases, the rock beneath each cutter is crushed and fractured. Eventually, these fractures meet and rock chips break away from the tunnel face. This process is known as kerf cutting. In mixed ground, the cutter head has a different design. Ground conditions for this type of head include highly weathered rock, clay with cobbles and boulders, or clay with seams of consolidated sand and gravel. The mixed ground cutter head is mounted with a combination of single or two-row carbide disc cutters, carbide bits, and scraper teeth. As the machine excavates, The disc cutters are slightly ahead of the soft ground tooling and allow cobbles and boulders to be fractured into smaller sections for passage through the cutter head. If the face is completely soft, the carbide cutter bits and soft ground tooling scrape the softer material from the face. Spoils are transferred onto the rotating full-face auger, which allows the muck to travel up and out of the casing through a door in the ABM's master pusher. To steer the SBUA, stabilizer pads located in each quadrant of the machine's shield can be manually adjusted. They are seen here as rectangular blue pads. A Dutch water level or electronic system can be used to monitor line and grade throughout the drive. As the SBUA excavates, new casing lengths are added and welded to the previous casing. At the end of a bore, the SBUA breaks through and is removed. The casing provides a lined tunnel in which to lay the carrier pipe. Robbins SBUs have been proven by hundreds of contractors around the world, from natural gas pipelines in the United Kingdom